Hello students, let us go for a few queries. First query is how to solve question number 2, fifth part, exercise 9.3. So here is the fifth part, 3m plus n, this is whole square, this is 3m plus 4n whole square, and then plus 4m plus 3n whole square, plus 4m plus 3n whole square. So you see that the question is divided into two identities separately and both are belonging to your what? A, B, again A and B, plus and then whole square. Here also plus then whole square. Again and again I am asking you to identify the identity first. You have to expand this, then you have to expand this, and the finally results you need to add. So identify what is A here. Here A is 3m, A square, because you know A plus B whole square is equal to what? That is A square plus B square plus 2AB. So expand that. A is 3m, B is 4m. A square plus B square plus 2AB means 2 into 3m into 4m. And keep this inside this bracket. And then similarly you expand the second one also. Again that is A square, but now your A is 4m and then B is 3n, so 3n square plus 2AB means 2 into 4m into 3n and close the bracket. Now you solve these brackets, so you can write the result within the small brackets. 3m square means 9m square, 4n square means 16n square, 2 3s are 6 4s are 24, all are plus, so plus will be there, 24 mn, and close the bracket. Similarly here also 4m square means 16m square, 3n square means 9n square, 2 4s are 6 3s are 18 mn, so this is 18 mn. Now you open the brackets. 9m square plus 16n square plus 24 mn plus 16m square plus 9n square plus 18 mn. Now write the like terms together. 9m square plus 16m square, this and this, then it is n square, 16n square and 9n square, and finally 24 mn and 18 mn plus 24 mn plus 18 mn. Now these two are like, these two are like, and these two are also like, so we can add these ones. 16 plus 9 will give you 25 m square, so this is 25 m square. Again 16 plus 9 is what? 25 m square, and 24 and 18 is 42 mn. So here you can leave your answer, 25 m square plus 25 n square plus 42 mn. So nothing is difficult. You take your time to identify the identity first. Here it is lying in the form of a plus b whole square. Again second part is second term, a plus b whole square. Then you need to add the result of these expansions. So both are a plus b whole square, a plus b whole square. Here a is 3m, b is 4m. Then you expand it according to this identity, expand it according to this identity, open the brackets, just write the like terms together, do the addition or subtraction, whatever is required, and finally you will be getting the answer. So that is the solution for question number 2, fifth part of exercise 9.3. So 2 parts already I have solved for you. Let us see how to solve the third part of question number 5. So here it is. Question 5, exercise 9.3 and part number 3. Question is, find the value of x if 46x is given equal to 68 into 68 minus 45 into 45. See, these all are the questions which are identity based. You are not allowed to go for the usual multiplications anywhere. So that's why 68 into 68 2 times it can be expressed as 68 square. Similarly 45 into 45 will make it 45 square. And now this is lying in the form of what? A square minus b square, where a is equal to 68 and b is equal to 45. So 46x, now a square minus b square, I know, is equal to a plus b. 68 plus 45 into 68 minus 45. So as the result of this product is 68 square, this product is 45 square. So a square minus b square, and a square minus b square is a plus b into a minus b. But what is a? A is 68, and what is b? B is 45. So 46x is equal to 113 into 23. So now x is equal to 130, 23 upon 46. Do the cancellation, and here you will be getting 113 upon 2 will be the value of x. You can express it in decimal form also if you want, otherwise you can leave it here also. So that will be the solution for your question number 5, part number 3 of exercise 9.3. The next query from the same exercise is question number 4, part number 6 and part number 9. So here I come to question number 4, part number 6. How to do this? Somebody is asking the help for this solution. Question number 4, 6th part is, here it is. Using identities, evaluate, that is 197 into 203. 197 into 203. Yesterday I shared one of the part, that was last part, 15th, 95 into 105. And at that time also I told you have to see to which ending zeros number this is close. Similarly this. So 203, you can have the very clear idea, is closest to 200. Similarly 197 is also closest to 200. And interestingly, you will find this is the difference of 203 and this is the sum of 203. So question are arranged accordingly. Now when I will subtract 3 from 200, I will be getting 197. So what I did, I simply expressed 197 in terms of 200 minus 3 because I was looking for the number with ending zeros closest to 197, and definitely anybody will find that is 200. Similarly to 203, I will be finding 200. So split it in terms of 200. In one side you have to minus and in one side you have to add, which is helping you to get this question back into the form of a minus b into a plus b, where in both the places a is equal to 200, b is equal to 3. Here also a is 200 and b is equal to 3, and the result is equal to what? A square minus b square. Now substitute what is a is 200 square and what is b is 3 square. So this will give you 4 with 4 zeros, that is 40,000 minus 9. So you subtract it and finally you will be getting the answer 39991. So that is the solution for this, that you can see finally. You can check it by doing the usual multiplication, 197 into 203, just to check your answer. But when the question is identity based, you are never allowed to do directly the multiplication and write the answer. Such answers will not be entertained. And the next query was how to solve ninth part of the same, that is of question number 4. So let us see what is there in ninth part. So ninth part of question number 4 is 61 square minus 59 square. 61 square minus 59 square. Straight away this is already lying in the form of a square minus b square. A square minus b square, where a is 61 and b is 59. And that is equal to what? A plus b into a minus b. So you just can express it in the form of a plus b. 61 plus 59. And a minus b means 61 minus 59. So here it is 120 and here it is 2. So that is equal to 240. So simple it is. But apply the identity very carefully. Your question is lying in the form of a square minus b square. And then the last query from someone was how to solve question number 2 of exercise 9.2. So in 9.2 we did not use any of the identity. So that is the question which is based upon your products of different terms as it is given in the question. Somewhere it is binomial with binomial, more than one operations you need to apply at a time. So please feel free to do the multiplications of binomial with binomial without using the identities in question number 2. And if you are finding any difficulty in particular part, then you please let me know that part. I will be giving you the solution for that. But exercise 9.2 is not based upon the identities, so you can go for your multiplication binomial with binomial, and then finally if it is simplification with respect to addition or subtraction, you apply as per the condition and then add or subtract the like terms, or then finally you can be there at last in your answer also. But still, if you are finding particularly in any of the part any difficulty, you please write it to me. I will be giving you the solution of that particular part. So that's all about your today's queries. And moreover, now your exercise 9.3 is also over, which was totally based upon your identities. I will repeat, you please make a note of that. First was x plus a into x plus b, and the result was this is equal to x square plus a plus b into x plus a into b. And second was I used, that was a plus b whole square, and I wrote that is always equal to a square plus b square plus 2ab. And third I used, that was a minus b whole square, a square plus b square minus 2ab. And fourth finally we used, that was a square minus b square is always equal to a plus b into a minus b, or vice versa also, a plus b into a minus b is always equal to a square minus b square. So these are the four identities of which applications we did in our exercise 9.3 in all the 5 questions and their parts. Please make a note of all these four identities and do practice. Try to write the questions of your own based upon these identities and check the results. Results you can check by your actual multiplication also. So try to write the questions with your own choice and then ask your parents even, or you send a question to me so that I can help you. Sir, I did this and please let me know the answer of this question. So I will solve that and then you can just evaluate yourselves. So this is the right time to do your self evaluations also. Moreover, tomorrow I will be coming with with an assignment based upon these 4 identities. At least 8 questions I will add to your assignment based upon these 4 identities, 2 each. So wait till tomorrow for the assignment. And if you want to start with the next exercise, that is 9.4, now we are going to start with the division. So only question number 1 I will be sharing with you of that exercise, where you have to divide any polynomial or any algebraic expression that is given to you by the given number. Like first question is find the common factors of the given terms. Now sorry, this is not 9.4. I will take you to 9.4 first. So in 9.4, carry out the following divisions. So very clearly there are 6 parts in question number 4. 1 or 2 I will be sharing with you. All of you are clear with the division also. Like here it is 88 a b square c cube, and you need to divide it by 22 bc square. So you do it as usual. A b square c cube divided by 22. So coefficient with coefficient and variables with variables. So what you can do is 21 ones are and 4s are. So here it is 4, sign will be of plus because plus divided by plus is always plus. So finish this part first, whatever you can do. If it is in fractions, but in lowest terms you have to write your answer. Then here you apply the law of your exponents. You know when the bases are same and getting divided, we need to subtract the powers. So A is alone, write A as it is. Now look at this, B square and B. So if it is B square upon B and power is 2, power is 1. Usually this is 2 minus 1, this will give me B. So I will write B. Otherwise, 1B will be getting cancelled with 1B. That is, B square can be expressed as B into B upon B. So B square I can write as B into B, and 1B is there. So I just can cancel it. In a rough margin, you can try in that way also. But better to apply the laws of exponent so that you can save your time. Similarly, C cube upon C square will be resulting into C only. Why? 3 minus 2 is 1. Or C 3 times C into C into C. When will be divided by C into C? 2 of the C's will go off. Only one C will left with your answer. So in that way, individually you start practices of doing this also. Suppose one more part I am taking, that is the sixth part of same question where binomial is divided by the monomial. So this is only the difference in this. Here it is minus 4a square plus 8 upon 3ab, and you need to divide it by minus 4a. So there are two terms. You can put it inside the bracket also. No issues. So then do it individually. With 4a you have to divide this also and this also. So you write it as minus 4a square upon minus 4a. First this with this, and then second plus 8ab upon 3 divided by what? Minus 4a. So do it nicely, take your time. Here so no problem is there. Minus will go off, 4 will also go off. A square when you will divide by a, so only a will left. Here you see, you know the procedure. This is the numerator, so you write the numerator as it is. When AB is written like this is always there with the numerator only. And here if nothing is there in the denominator, you always put 1. So minus 4a upon 1. So into when you will be taking, so you need to take the reciprocal all the times. Now you see, a you can cancel with a, 4 1s are and 4 2s are. A is here, plus divided by minus will always result into minus. 2b into 1, only 2b will be there, and 3 into 1, 3. So a minus 2b upon 3 will be the answer for this. So take your time, do the calculations comfortably, see what procedure we need to divide. This was the numerator and this was the denominator, because I need to divide this whole by this. So if minus 4a is there, you put 1 in the denominator, then I know the numerator is this, and when I need to transfer the denominator into, so I have to always take the reciprocal. Then whatever the possibilities are there of cancellation, please go for that, and keep a check upon the signs. This is very important in algebra. If this is plus and this is minus, I know very well that plus divided by minus always results into minus. So minus will always be there, and the rest of the part is there in front of you. In that way, you can try these 6 parts of your question number 1 for today at your home. Then next parts I will be touching tomorrow, followed by an assignment based upon your 4 identities which we discussed in our previous exercise. Thank you.